Welcome back to the Deep Dive. Today we are jumping into something absolutely fundamental to modern tech, cloud storage. Specifically, we're looking at how Microsoft Azure handles that huge, messy world of unstructured and semi-structured data.
That's right. And look, for anyone building or managing systems in the cloud, understanding the Azure Storage account isn't just nice to have, it's non-negotiable.
Right.
So our mission today is to give you a quick, really clear guide to the 5 core services that live inside it.
We're talking blob, file, queue, table, and disk storage.
Yep, all 5. We want you to walk away knowing exactly which tool to grab for which job.
I have a lot of ground to cover.
Yeah.
We're going to define the data itself, then dive into the storage account, and then, hit each of those 5 services one by one. And our goal here is to get past just the definitions. We want to understand the why, the use case, the cost, all of it. Okay, let's unpack this. And the place to start, really, is with the data itself. Before you can store anything, you have to know what it is.
You have to. And our sources lay out 3 main categories.
Okay.
Understanding these is the filter for your whole cloud architecture.
Okay, so what's the first one?
First up, you have structured data. This is your classic database world.
Nice and neat. Relational.
Exactly. Everything is organized by a specific fixed schema. You have defined properties, relationships between tables. It's predictable. We'll actually save a full discussion on that for a future deep dive because it's its own universe.
Okay, so after structured, what's next?
Then you have semi-structured data. And this is where things, they start to get really interesting.
It's like a bridge between that super clean database world and just chaos.
It is. It uses tables, but, and this is crucial, each row does not have to follow the same rigid schema as the one next to it.
So one row could have a name column and the next one doesn't.
Precisely. The only thing they usually have in common is some kind of ID or key. Think JSON, XML. It gives you incredible flexibility and speed.
And then there's the third category, which is probably the biggest.
By far the biggest. Unstructured data.
And this is just everything else.
Everything else. Images, movies, application files, backups, PDFs, logs. If it doesn't fit neatly into a spreadsheet cell, it's probably unstructured data.
And that distinction is so important because if you have unstructured files, you're looking at blob or file storage. Semi-structured, you're thinking more about table storage.
That brings us right to the main service, the umbrella for all of this, the Azure Storage account.
So this is the container that holds all 5 of these services we're talking about today.
It is. And it's designed for 2 things above all else: high scale and high durability.
When you say high scale, what are we talking about?
We're talking petabytes. You can store just a massive amount of data. But the durability, that's what's really jaw-dropping.
Okay, the sources gave a number for this that just seems unreal.
It does. By default, even with the most basic setting, you get 11 nines of durability.
11 nines. What does that actually mean for someone listening?
It means the calculated probability of you losing your data is so low, it's hard to even conceptualize. It's 1 in 100 quadrillion. It's astronomically low.
And that's not just a marketing number. That has real architectural implications. It means the cloud itself is so robust that you might not need all those complex, expensive backup systems you built on premise.
Absolutely. That durability sets the foundation. So let's see how that foundation applies to the most common service of all.
The blob.
Azure Blob Storage. It's the most general-purpose service, and it's designed specifically for all that unstructured data we just talked about.
And blob just stands for binary large object.
Yeah, it's basically just a synonym for file. If you want to put any kind of file in the cloud and get to it over HTTPS, this is probably your first stop.
And inside blob storage, you have containers.
Right. You can think of a container as just a bucket or a folder that holds all your individual blobs, all your files.
So this is what you'd use to serve, say, a profile picture on a website or let a user download a PDF.
Exactly. It's for both your applications and your users to work with those files.
But here's where it gets really interesting from a business perspective. The pricing, the tiers.
Yes. This is a masterclass in how to optimize your cloud spending, because not all data is created equal.
Not all files are accessed with the same frequency.
Not at all. So you have 3 tiers. First is the hot tier.
Hot, as in you're using it all the time.
Constantly. This is for frequently accessed data that needs to be available instantly. Think of the images on a busy e-commerce site. It gives you the best performance, but it also has the highest storage cost.
Makes sense. So what's the next step down?
That would be the cool tier. This is for less frequently accessed data.
Like backups or older project files.
Perfect examples. Data you might access once a month. You still get that incredible durability, but you trade a little bit of performance and availability speed for a really significant discount on the price.
And then there's the deep freeze.
The archive tier. This is for files you almost never plan to access.
We're talking long-term regulatory backups you have to keep for 7 years, that kind of thing.
Exactly. It has the absolute lowest price per gigabyte. I mean, it can be 10 times cheaper than the cool tier.
But there's a big catch.
A huge trade-off. Getting your data back isn't instant. It might take several hours.
Why so long?
Because that data is physically moved offline, it's taken off the expensive, always-on spinning disks and put onto deep, cold storage systems like magnetic tape libraries, so it costs almost nothing to store it, but there's a rehydration fee and a time penalty to get it back.
So the bottom line for you, the listener, is if you can figure out how often you'll need your data, you can save an absolute fortune.
A fortune. Don't pay hot prices for archive data.
Okay, so that's Blob storage. Let's move on to the second service that handles files, and this is where I think a lot of people get tripped up, Azure File Storage.
Yeah, because on the surface, they sound almost identical. It stores files.
Right. I see in the sources that it uses files instead of blobs and shares instead of containers.
Semantically, yes. It's pretty much the same.
So, is a share just a container with a different name? Or is there a real functional difference?
There is a fundamental difference in how they function, and it all comes down to the access method.
How you get to the files.
Exactly. Blobs are accessed over HTTPS with REST APIs. File storage is accessed using the SMB protocol, server message block.
SMB. That's the protocol for Windows file sharing, right? That feeling of right-clicking and mapping a network drive.
That's the one. That same simple protocol is what powers this cloud service. You can make a file share in Azure appear on your computer just like a C drive or a D drive, but the files are actually being saved in the cloud.
And that ability is huge for companies trying to move to the cloud.
It's critical. It drives two main use cases. First, as an extension of on-premise file shares. A company's internal file server is getting full, so they just extend it with an Azure file share. The users don't even know the difference.
Seamless. And the second use case?
The big one. Lift and shift.
Moving old applications.
Exactly. Imagine you have an old app that's hard-coded to save reports to, say, the R drive, instead of rewriting that whole application, which could be a nightmare.
You just mount an Azure file share as the R drive.
You got it. The app doesn't change at all. It keeps working just as it always has, but now its files are being saved safely and durably in Azure. It's a brilliant bridge for legacy systems.
That SMB connection really is the defining feature. Okay, so we've covered storing large files, but what if we're not storing files for a user at all? What if we're storing tiny little bits of information just for processing?
Now you're moving away from passive storage and into active system architecture. That brings us to Azure Queue Storage.
A small service, but the sources say it's incredibly important.
It's one of the keystones of building scalable, decoupled applications. It does one simple thing. It stores tiny pieces of data called messages.
Okay, give me an example.
Sure. Imagine your web app generates a really complex report that takes, 3 minutes to run. You don't want the user just sitting there staring at a loading screen.
No, that's a terrible user experience.
Right. So instead, the web app just drops a tiny message into a queue. The message just says, hey, generate report 407 for user X. That's it. The web app is now free.
And it can tell the user, we're on it, check back in a few minutes.
Exactly. Then you have background processes called workers that are just watching that queue. They pick up the message, do the heavy 3-minute processing, and the front end is never blocked. It's how you build systems that can handle massive, unpredictable workloads.
It decouples the different parts of the application.
Yeah.
Very cool. Okay, let's switch gears from processing to data storage again, but this time into that semi-structured world, Azure Table Storage.
Right. Table storage is your lightweight NoSQL database option inside the storage account. It's built specifically for those semi-structured needs we talked about earlier.
So no fixed schemas.
No fixed schemas, no foreign keys, no joins. It stores multiple tables, but it's pure flexibility.
And the sources really emphasize its speed and scale.
It is engineered for incredibly fast access. We're talking. Even with petabytes of data, you can retrieve a specific row in milliseconds.
If you use the right key.
If you use the compound key, yes. And that schema flexibility is where it really shines. You could have one row in a table representing a customer with properties like first name and city.
And the very next row.
The very next row in the exact same table could be a product with properties like SKU and price. The service just doesn't care.
That's amazing for development speed. But if there are no schemas or joins, how do you handle data quality? I mean, what's the trade-off here?
That's the critical compromise. The data quality, the consistency, That's now the responsibility of your application code, not the database.
Ah, so the complexity moves from the storage layer up to the developer.
Precisely. You gain phenomenal scale and speed, but you lose the built-in integrity checks of a traditional relational database.
A necessary trade-off for that kind of scale.
Mhm.
Okay, that brings us to our fifth and final service, which is very specialized. It's all about infrastructure, Azure Disk Storage.
This is basically disk emulation in the cloud. It's used to attach persistent storage to your virtual machines.
So when you set up a server, a VM, you have your C drive for the operating system, maybe a D drive for data. This is that.
This is that. It provides that permanent storage layer, and you have choices. You can pick high-performance SSDs for your production databases or cheaper, slower HDDs for, a dev test server to save money.
And there are two ways to manage them, unmanaged and managed.
Historically, yes. With unmanaged disks, each disk was just a file in Blob storage, and you, the customer, had to manage the capacity of that whole storage account. It was cumbersome.
So what's the standard now?
The standard now is definitely managed disks. The experience is so much simpler. Microsoft handles all the back-end complexity. You don't worry about blob storage or capacity planning. You just say, I need a 1 terabyte disk, and Azure gives you a 1 terabyte disk. It's that easy.
Okay, so let's try to bring this all together for everyone listening.
Let's do it. The Azure Storage account is your highly scalable, incredibly durable foundation for all unstructured and semi-structured data. Inside it, we've defined 5 distinct tools for 5 distinct jobs.
You've got blob storage for your general purpose files like website content, and you can optimize costs with those hot, cool, and archive tiers.
Then you have file storage for when you need that classic shared drive experience using the SMB protocol, which is perfect for legacy apps.
We covered queue storage for building those scalable asynchronous systems that use messaging to decouple your application parts.
And table storage, your fast, flexible NoSQL option for semi-structured data when speed is everything and a fixed schema would just slow you down.
And finally, disk storage, providing those essential persistent drives for your virtual machines, mostly consumed now as managed disks to make life easier.
That's the roadmap. If you understand those 5, you can make really smart, cost-effective decisions about where your data lives in Azure.
So you now have the map to choose the right tool, and just as importantly, the right price point for pretty much any file or message storage you'll ever need.
Absolutely. And that leads us to a final thought for you to take away from this deep dive.
Thinking about that incredible 11 nines of durability that's just built into the Azure Storage account by default. What complex, maybe expensive on-premise backup or redundancy system could you now confidently simplify or maybe even turn off entirely just by trusting the cloud's foundation?
Something to think about indeed. Until the next deep dive, happy learning.